Good afternoon, our listeners, and welcome to our today's class. Today, we are still continuing in discussing the measures of central tendency and dispersion. Do remember that in our previous classes, we already had started talking about these measures under an array of data and ungrouped frequency table. Today we are going to make effort, or we are going to extend our effort towards discussing these measures under the grouped frequency table. But before then, it is important that we equally look at another measure in statistics called measures of partition. So we can equally discuss it now for an array of a data, equally discuss it now for ungrouped frequency table. So that at the end, we come on the same page to discussing these measures under grouped frequency table. So the beginning of our class today is with the measures of partition. The measures of partition. So generally, we have three measures, and these measures are measures of central tendency, though is an also extension of the measures of central tendency to have the measures of partition, and we equally have what we call measures of dispersion. Today we are going to talk about measures of partition. Measures of partition. Measures of partition. Measures of partition. In the measures of partition, we are going to look at number one. We are going to look at what we call quartile. We look at quartiles. Number two, we are going to look at deciles. Number three, we are going to look at percentiles. Percentiles. And of course, when we talk about measures of partition, we are talking about some concept that divide a data set into equal parts. So the beginning of it now is what we call the quartile. Of course, when someone uses the word quar, the person is talking about what for. So this, of course, is a measure that divides a data set into 4 equal parts. That's what we mean by quartile, beginning with the word quar. Then when we talk about decile, we are talking about 10, and we now talk about a concept or a measure that divides a data set into 10 equal parts. And then when we talk about percentile, we are talking about what? 100. And we are talking about a measure that divides a data set into 100 equal parts. This is a sketchy explanation of the quartiles, the deciles, and the percentiles. So we are going to look in details on these measures beginning from the quartile. So let me clean this board and start with the quartile. Thank you very much. So we are talking about the quartiles. Talking about the quartiles. Okay? I really want us to understand in detail what quartile is and how one can go about computing them from a given data set effortlessly. So let us now do some illustration to showcase in details what we mean by quartile. Let's, for instance, consider that this line from here to here is talking about what? A data set or a distribution. And we earlier had said that the quartile divides a distribution or a data set into 4 equal parts. So let us try to partition this line into 4 equal parts to be able now to see clearer what we mean by quartiles. Now let us consider a line at the center first. This is a line at the center. Then let us now consider a line equally here. And let's equally consider a line here. I want us to count the parts of this line. We have the first, the second, the third, and then the fourth parts. Therefore, these strokes of line 1, 2, 3 have been able to divide this distribution or data set into 4 equal parts. So we are now going to say that this first stroke now is talking about what? Q1. And this Q1 is equally what we call the first quartile. The first what? Quartile. And then we have what we call Q2. This is what we call the second quartile. And then we have what we call Q3, which we call the third quartile. Okay? So oftentimes you hear people talk about the first quartile, the second quartile, and the third quartile, and not necessarily talking about what the Q4, which is the fourth quartile. Because this line equally have divided this data set into 4 equal parts. However, there are some statements that people make which oftentimes people just believe without necessarily knowing why it is so. It is said that the second quartile is the same thing as the median. So how is the second quartile the same thing as the median? Let us equally take what? A data set or a distribution. So if I take a data set or a distribution that goes this way, for instance, I have a data set or distribution. It goes from here to here. The same line with that first one. I have this and I have this. We are told that a median is a number that divides the distribution into 2 equal parts, or divides the data set into 2 equal parts. So I am going to divide this line into 2 equal parts. And then when I do so, I'll be able to have a line at the center here. And this line at the center here divides this distribution into 2 equal parts. And if you watch, if you trace this line up now, this line agrees with the second quartile. Of course, here is what we call the median. This is what we call the median. So now if you watch now, this median line, if it is drawn up now, it coincides with the what? The second quartile. Therefore, the second quartile is the same thing as the median, or the median is the same thing as the second quartile. So oftentimes you see people write that the median, that what? The median equals what? Q2 equals the second quartile. Okay? Now we are equally told that the quartiles are special kind of percentiles. So how do we relate the quartiles with the percentiles? So that when they begin to say that the first quartile is the same thing as the 25th percentile, and then the second quartile is the same thing as the 50th percentile, and then the third quartile is the same thing as the 75th percentile. How do we see that picture clearer from these illustrations? Let us equally consider another line, and that line runs from here to here, which is the same thing with this line I've drawn before. This is this way and this is this way. Now, of course, you do remember that here is the center, here we have a line, and here we have a line. And then that's the reason why we call here what? Q1, we call here what? Q2, and we call here what? Q3. And do remember that when we talk about percentile, we are talking about a measure that divides a data set into 100 equal parts. That is what we call a percentile. Okay? However, what we have here is 3 lines that divides this line into 4 equal parts. And of course, if I have 4 equal parts, for me to be able to get 100, it means that one part from these 4 parts have to be 25. That is to say that from here to here is 25, from here to here is 25 to give me 50, from here to here should be 25 to give me 75, and from here to here should be what? 25 to give me 100. Therefore, if from here to here is talking about what? 25th percentile, that from here to here is talking about what? 25th percentile, and then from here to here is 25 again, adding to this will bring me to 50th percentile. I'll equally add 25 from here to here, which when added to 50 will bring me to 75th percentile. And then when I add 5 here now, I'll be able to arrive at what? At the 100. We now find out clearly that the first quartile corresponds to what? The 25th percentile. Then the second quartile corresponds to the what? 50th to what percentile, which equally corresponds to the what? To the median. And then our third quartile corresponds to the 25th percentile. So these are the reason why oftentimes you hear people say that the second quartile is the same thing as the median, the first quartile is the same thing as the 25th percentile, the second quartile is the same thing as the 50th percentile, and then the third quartile the same thing as the 75th percentile. I really want to believe that you must have got some clearer picture on why people make that kind of generalization without necessarily laying emphasis on how they came to be. So permit us now to clean here, say a little thing again about what the quartile, and then go over to taking some examples now, and then showing how we can calculate our quartiles from these illustrations or examples. Thank you very much. What do we really mean when we talk about the first quartile and when we talk about the third quartile? What do we necessarily mean when we talk about what the second quartile? When we talk about the first quartile, we are talking about that the 1/4 of the observations, 1/4 of the observations lie before Q1. That's what we mean by first quartile. That 1/4, 1/4 of the data set or the distribution lie below Q1. But when we talk about the third quartile, which is the third fourth, 3/4 of what? Of the distribution or of the data set lie above Q3. This one, 1/4 lies below. This one, 3/4 lies what? Above. But when we talk about what? The median, or what we call the second quartile, we are talking about the 2/4, which is of course what? 1/2. That of course half of the distribution or the data sets lie below this, and equally half of the distribution lie above that. That is the explanation that we can equally give on the second quartile. But let me now show you why some persons say that the first quartile is the median of the first half of the distribution. And then the third quartile is the median of the second half of the distribution. Do remember that if I have that here is half, which is the median, that if I draw a line from here to here, then I have this and I have this. And you remember that this place now is what we call the Q2. Okay? So I can then come and clean off here, then have an arrow this way and have an arrow this way. Here is referring to what? My Q2, which of course, from here to here is half of the distribution, and from here to here is a half of the distribution. And of course, we know that median is a measure that divides a data set into two equal parts. So I want us now to be looking from here to here as a data set. For us to get the median, we are going to get this center here. We are going to locate the center here. And then this is what we call the median. And of course, this is what we call the Q1 because it agrees with this. Which means that the Q1, which is the first quartile, is the median of the first half of a data set or distribution. We equally begin to look from here to here as being a distribution. And we talk about a median, which is a number that is going to divide this line into two equal halves. So I also have something here, which I'm going to call what? Q3. And of course, you know that when I'm looking at from here to here as a distribution, this my Q3 now is the median. And of course, this median now is talking about for the second half of the distribution. Therefore, the Q3, which we call the third quartile, is the median of the second half of what? Of the distribution, while the Q1 is the median of the first half of the distribution. So that when we begin to take measurements and the rest of them and make emphasis on this thing, you will equally be carried along. Sincere effort is being made to make sure that we extray a lot of difficulties that are surrounding these measurements and be able now to give a clearer picture on how they can be computed effortlessly. So permit me to clear here while we now talk about quartiles and then take some examples. Yes. Of course, when we talk about quartile, we are saying dividing a data set into 4 equal parts. But first of all, you must have arranged these words data set in ascending orders of their values. Just like we usually do in median, because median acts as a measure of what central tendency and equally act as a measure of what of partition. Because median equally divides a data set into 2 equal parts. So it is a measure of what of partition. Okay? So meaning that once we are giving what values now, we must first of all now arrange the words or the numbers now in ascending order of their magnitude or values before we begin talking about either median, either quartile, either percentile, or either decile. So there are 2 ways of calculating what the quartiles, 2 ways of calculating the quartile for an array of what a data or for an ungrouped frequency table. So we are going to talk about now then calculating of what of the quartiles now for an array of data and ungrouped frequency table. For an array of data, array of what? Of data, and then for ungrouped frequency table, ungrouped frequency table. For ungrouped frequency table. Okay? So for an array of the a data, the first method we have for the array of the data is that you by yourself arrange the numbers in ascending order of their values and be able to use your hand and locate the center of the distribution, call it what your second quartile, then locate now the center of the first half of the what of the data set, call it your Q1, and locate the center of the second half of the distribution and call it what your Q3. Or you are going to use a formula method. You are going to use what? A formula method. So number 2 is by arrangement and locating the center of the distribution called median, finding the median of the first half and finding the median of the second half. And then number 2 is by the use of the formula. By the use of formula. These 2 approaches apply to the array of data and then for ungrouped frequency table. And when we talk about using a formula, we are not talking about using a formula to find the mean or to compute the value of a quartile. We are talking about using a formula to locate the position of what of the quartile. So the question is, what is that formula I am going to use to locate the first quartile, the position of the first quartile? What is that formula I'm going to use to locate the position of what the second quartile? And what is that formula I am going to use to locate the position of the third quartile? We are told that for the first quartile, the formula we are going to use to locate is what? Is Q1 equals, I have what? N plus 1 all over what? 4. That is for Q1. Then for Q2, I am talking about Q2 is given as what? 2 into N plus 1 all over what? 4. And of course, I have 2 here and I have 4 here. So these 2 can cancel 1 and cancel this to give what? 2. And what I have here becomes N plus 1 all over 2. Then as for the Q3, I have that Q3 is given as what? 3 into what? N plus 1 all over what? 4. And we should be very, very careful that as we are using this formula, irrespective of whether the sum of our observation is even or odd, we are going to use this formula. Irrespective of whether they are even or odd, we are going to pay attention in using this formula. Okay? So what I'm going to do now is I am going to clean this board. We draw a set of observation, calculate it using our usual manual method in number one, and number two, resort to using what we call the formula method to be able to know whether we are going to get the same thing. Thank you very much. So permit me to clear here. First of all, I'm going to begin, I will give an array of data. Where we are done in array of data, solving it this way and solving it this way, we come back now for ungrouped frequency table and then be able to solve it using formula. Because when we say let us enumerate all the values contained in the table, it might be too cumbersome for us to be able to manage the time meant for this class. So thank you very much. So we now have what we call example one. That's what we call example one. Example one. In this example one, let us say that we have observations line. We are saying, let us have observations line. Maybe 0, maybe 2, maybe what? 1, maybe what? 3, maybe 2 again, maybe we have 4, 1, 2, 3, 4, 5, 6, and then maybe we have 7, and maybe we have -1. And the question here is that we are to find, the question here is find our Q1, Q2, and Q3. That is the question they ask us here. Find Q1, Q2, and Q3. So what we are going to do first of all is to write solution, After solution, we come and then arrange this number in ascending order of their values. So to arrange them, of course, the least number I have here is -1. Then I have -1, comma. Followed by what? 0. So I have 0, comma. Followed by what? 1. I have 1, comma. Followed by 2, which of course occurred 2 times. Then followed by what? By 3. Followed by what? By 4, and followed by 7. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we first of all go to locate the center here in this particular thing. Or to make this thing simpler, let us not have, because there is something I'm seeing here which I'm going to give an explanation to about having these 2 and these 2 here. Let me say that I have what? These 2 here. Then I have something like, let me say I have a value here, like what? Like 8. Let me call it a value 8. So that in that case, I won't be able to have this anything here, and I'll be able to have 8 here. I will explain why I had to do that adjustment I did. So permit me to clean here. So what I have is -1 for this -1, 0 here, 1 here, 2 for here. The next thing becomes what? 3. The next becomes what? 4, and the next becomes 7, while the next becomes what? 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So let us first of all use the first approach by manually doing this. So we now go ahead. When we go ahead now, what we are going to have here is what? We try to locate the center of this. If you count 1, 2, 3, 4, you count 1, 2, 3, 4, you find out that the center is here. The center of the distribution is supposed to be here. So I'll be able to draw a line that goes this way, come here, and draw a line that goes this way, come here, pointing that here is going to be what? The center. But if you look at this center, you find out that there is no value that is there. So what you do is to add the number at the left of this particular point and the number at the right of this particular point in order to get your what? Your Q2. So for me to get my Q2, I'll be able to say that my Q2, which of course is equals to what? Median, is given as what? 2 plus what? 3, all over what? 2. And of course, 2 plus 3 is equals to what? 5 all over 2, which is equals to what? 2.5. So what we have here is 2.5. And what we are saying by this 2.5 is that half of the distribution or half of the data set lie below 2.5 and above 2.5. That's what we are saying about median. Half of the data set of the distribution lie below 2.5 and then above 2.5 for it to be the median and equally be the Q2. Then there is something we need to note here if we must be able to find our Q1 and Q3 successfully. What we are going to note here is that this 2.5 is not a data set in this distribution. It is not a data set. But of course, it is called the median. And what we are saying that every other data set, that half of it lie under this 2.5. And then you come back here for you to get half of this distribution. For you to get this half of this distribution, this minus 1 here, it lies below this 2.5. This 0, of course, it lies below this 2.5. This 1, of course, lie below 2.5. These 2, of course, believe me, lie below 2.5. The only thing that did not lie below 2.5 is what? Is this 3. So in this case, the observations, the half of the observation that lie below this 2.5 is this minus 1, this 0, this 1, and this 2. It is from this half of this distribution that you are now going to find your what? Your Q1. And we have been told that our Q1 is the median of the first half of what? Of the distribution. And this is the first half of the distribution. So for me to find the median of this one, I'll count 1, I'll count what? 1. So if you want to look for the center, 1, 2, 1, 2, you find out that the center lies here, the center lies here. And because the center lies here and there is no observations here, we are going to sum these two observations and divide by 2. So we now say, therefore, that my Q1 is given as 0 plus 1 all over 2, which is 1 over what? 2, which is, of course, 0.5. And what we are trying to say is that 1 over 4, 1/4 of the distribution lies below 1 over 2 of the data set or of the distribution. Then we now come now for this other part. You bear me witness that this 3 lies above this. So I have 3 here, 4 lies above this, 4, 7 lies above this, 7, and 8 lies above that, 8, So for you to find the Q3, you are now going to look for the median of this second half of the distribution. And of course, the median is going to be 1, 2, here you do like this, 1, 2, you do like this. It is here. And there is no observation there. So you sum the number behind and the number after it, and be able to have that your Q3 is given as, you have 4 plus what? 7 all over 2, which is what? 11 all over what? 2, which should be something like 5.5. And then we call it now what we call the third quartile. Of course, do remember that this 1 over 2, which we call the first quartile, is the same thing as the 25th percentile. And equally, do remember that this our Q3 is the same thing as the 75th percentile. And then this median, which we got here, 2.5, is actually called the 50th percentile. So this is how to rally around this particular thing. The value we have for median is 2.5. The one we have for Q1 is what? 1 over 2. The one we have for Q3 is what? 5 over 5.5 or 11 over 2. So permit me to clean here, or let me report this value that we have here. Let me report the value here. We have that our Q1 equals what? 1 over what? 2. My Q was 2 equals what? 2.5, which is 5 over what? 2. And then my Q3 equals what? 11 over 2. So we can try using the second approach, which is called the formula method, to be able to know whether we are going to get this. Pay attention. We are doing something very, very serious. that can be very, very confusing under exam situations if you do not have the facts in your fingertips. So permit me to clean. So we are going to use the second approach, and that second approach is talking about formula method. Then in the formula method, we are given the formula for Q1, formula for Q2, and the rest of them. That's what we are given. Okay? So when we now have formula for our Q1, what we are now going to have is our Q2. We start with our Q2. Our Q2 is given as what? N plus 1 all over what? 2. Remember that it was what? 2 into n plus what? 1 all over what? 4. But when these 2 cancel, here is 1, cancel 4 is 2, and you have that this is n plus 1 over what? 2. Where this n is the number of observations in the data set. And in our own case, the number of the observation in this data set is what? Is we have it to be what? 1, 2, 3, 4, 5, 6, 7, 8. Okay? So we now have that this equals what? Here is what? 8 plus 1 all over what? 2. And then this becomes what? 9 all over 2, which becomes 4.5. Becomes 4.5. Then because I've got 4.5, I am now going to first of all arrange this my observation in ascending order of their values and be able now to locate the position of this 4.5. And how to do that, of course, we have done it before. It will start with minus 1. I have minus 1, comma. I have what? 0, comma. I have what? 1, comma. I have what? 2, comma. I have what? 3, comma. I have 4, comma. I have what? 7, comma. And I have what? 8. Then we go ahead and locate our 4.5, beginning from the least observation. So we have 1, 2, 3, 4. This is where we have 4. And what we have here is 4.5 and not 4. So 4.5 lies here. That's the implication. 4.5 lies here. And because 4.5 lies here, we are going to add this observation here and add these observations here and divide by 2 for us to get our Q2. So we now have that Q1. That Q1 is given as, my Q2 is given as what? We have 2 plus, this is Q2. It's given as 2 plus 3 all over what? 2. Which is 2 plus 3 is what? 5 all over what? 2. And do remember that we got that Q2 here is what? 5 over 2. Which gave us what? 2.5. Now, we have seen that 2.5 is another data set that exists here. For it now to act as what? As the median, the value that is at the center. So for you to be able to use this formula value to find your Q1 and Q2, you are going to assume that you no longer have 8 observations here. That what you now have is what is 9 observations. Because there is 2.5 that you have come to know is also an observation here. For it now to be the number that divides this data set into 2 equal halves. So you are going to adjust the value of your n. That is the most important thing that I want you to hold in this lesson. Or one of the most important things I want you to hold here. That the moment you have got your median, which is what your Q2, and it happens to be a value that is not captured in the data set, it is believed that the data point has increased and we adjust it. And look at what I'm going to do to know whether we are going to arrive at these answers. So permit me to clean this up. Okay. So when I do something, I want to go and find my Q1, and finding my Q1, of course I have adjusted that my n now is no longer 8. N has become what? 9. So I'll be able to have that my Q1 is equals what? We have n plus what? 1 all over what? 4. I will now say, but my n now equals what? 9. So that I will be able to have that this equals what? 9 plus 1 all over what? 4. Which becomes 10 all over 4, which becomes 2.5. This my 2.5, of course, is not the what? The median. Sorry, it's not the what? The Q1. is the locator of the first what quartile in the data set. So I will now come and begin from the beginning to count. And I'll have 1, I have 2, I have what? 2.5 to be here. This is 2.5. It lies at this center, 2.5. So because it lies at this center, 2.5, I am going to pick what is behind and what is what after it. Therefore, I'll be able to say, therefore, this my Q1 is given as 0, which is below it, plus 1, which is above it, all over 2, which is 1 over 2, which is what we got here. I want to assure you that the moment you drop this, the moment you do not bring in this idea that the value of your data set has increased, and you retain this now to be what? 8 now, you might have here now to be 8 plus 1, which is what? 9. And 9 all over what? 4 might not be able to give you something 0.5 to lie at the center here. That can justify that average of this thing will be able to locate that center. So what I'm going to do for Q3 now becomes that my Q3 is given as the locator formula is 3 into n plus 1 all over 4. And of course, my n has become 9. So this thing becomes what? 3 into 9 plus what? 1 all over what? 4. And of course, this is 9 plus 1 is what? 10. Multiplied by 3 is what? 30. So I have what we call 30 all over what? 4. 30 all over what? 4. And if you press 30 all over 4, I think it might give you something like 5.5 or thereabout. So on that case now, you now count 1, 2, 3, 4, 5. And like I told you earlier, once you count it now to be 4 and 5 here, it will locate you to this value here. And you are talking about 5.5, which brings you what at the center here? Brings you what at the center here? So when it brings you at the center here now, you'll be able to have now, so let me now check exactly what this and 30 all over 4 could be. I think it is 6 point something, not 4, not 5. If here had been 5, we should be talking about what? 5. You understand? So I think it should be 6 point something. And that should be 1, 2, 3, 4, 5, 6. And then it will bring you at the center here. Sure, it is 6 point something. It will bring you at the center here. And when it will bring you at the center here now, of course, you are going to say 4 plus what? 7 to give you what? 11 all over 2. And that's what we have here, 11 all over 2. So this is actually how to obtain the value of your Q1, your Q2, your Q3, and next one. Most especially when you have even number of what? Of observations. So we are going to call up what? An example that is odd in nature, and then see how we go about it now very fast. So permit me to clean this. Permit me to clean this while we still carry you along. Thank you very much for following us. I'm going to call that one example 2. So I have e of x dot what? 2. And let me say that e of my x dot 2 still starts with what? Either minus 1, either 0, either 2, either 3. Then I have 5. I have minus what? 2. I have what? 4. And I have 9. 1, 2, 3, 4, 5, 6, 7, 8. And perhaps I have 11. This is what I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. This is odd number of observations. Odd number of observations. So in the odd number of observations now, what we are going to do now is for us to now to find. So we are interested in still finding our find our Q1, our Q2, and our Q3. And on doing this, of course, we arrange the number in ascending order of their values. And the least number here is minus 2. So I have minus what? 2. Then I have followed by minus 1. Then followed by 0. Followed by what? 2. Followed by 3. Followed by 4. Followed by 5. Followed by 9. And followed by 11. So that's what we have over there. Permit me to remove something that came on top of the screen. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we locate the center of this distribution. The center is now going to be 1, 2, 3, 4. 1, 2, 3, 4. This is the center, which is talking about the median or the Q2. So which means my Q2, which is the second quartile, which is equals what? Median equals what? 3. Then for me to find my Q1 and Q2, we are told that I'm going to consider getting the median of the first half of the data set. Now here is the median that has divided this into 2. Half lying below it. I'll come and concentrate here. Because fortunately that this 3 is part of my data set. The 3 is part of my data set. So these 2 equally, it lies below 3. So I'm going to stop at this. I'm not going to include the 3 because 3 is equal to 3 and doesn't lie below what? 3. So the first half of my data here becomes what? Minus what? 2, minus 1, 0, and what? And 2. So I'll be able to say that my Q what? 1 here is now going to be getting the median of this. And I'm going to say 1, 2, 1, 2. So the median, it lies here. So I'm going to add the number behind and the number above. And it becomes minus 1 plus 0 all over 2, which becomes minus 1 all over what? All over 2. Then the second half of what? Of the data set is what we have as 4, as 5, as 9, and as 11. And as usual, I will be talking about what? The Q what? 3. And I'm talking about the median of the second half. So I'll say 1, 2, 1, 2. It lies here. And because it lies at the center, I'm going to add this and this together. And then I'll be able to have what? That this equals 5 plus what? 9 all over what? 2. Which of course becomes what? 14 all over what? 2. Which perhaps becomes what? 7. So this is our what? Our Q1 minus 1 over 2. Then our Q2, 3. And our Q3 is what? 7. So permit me to list it here. So that when we go to formula method, we will now be able to know whether we are going to get the same thing. Our Q1 is minus 1 over 2. Then our Q2 is given as what? 3. And then my Q3 is given as what? 7. This is using the free method. So let us now go ahead now and then clean this particular place. So when I clean this particular place here now, I clean this place. Okay, so I'm going to use the formula method. And the formula method I'm going to use, I will say that my Q2, which of course is the median, is given as 2 into n plus 1 all over 4, which is the same thing as n plus 1 all over what? 2. Our n here is 1, 2, 3, 4, 5, 6, 7, 8, 9. N is 9. So this equals what? 9 plus 1 all over what? 2. This becomes what? 10 all over what? 2, which is equal to what? 5. So I'm now going to start from the beginning and get to the fifth what? Observation, and it becomes what? The median or the Q2, which means I have 1, 2, 3, 4, 5, which is Q2 is given as what? As a 3. Then I will now go ahead now to what? To Q1. I will now have what? My Q1. When I have Q1 now, there's no data set. The median took a value that is contained in the distribution. So no new observation is what is introduced. Okay? So there is no need adjusting the value of what? Of n. N still remains what? 9. Because no new observation was introduced. And of course, we know that Q1 is given as what? N plus 1 all over what? 4. And where in this case now, this my n now is what? Is 9. So this becomes 9 plus 1 all over what? 4, which is what? 10 all over 4, which is 2.5. When I have it to be 2.5, I will come over here. I will count 1, 2. 2.5 should lie in between here. And when 2.5 lies in between here, we add what is below it and what is what? Above it. Which in this case now becomes that my Q what? 1 is given as minus 1 plus 0 all over what? 2. Which is what? Minus 1 over 2. Which was what we got earlier. Then we move over now to our Q3. We have that our Q3 is given as what? 3 into what? N plus 1 all over what? 4. N didn't change. N still remains what? Our 9. So we have that this is what? 3 into what? 9 plus 1 all over what? 4. which becomes what? 3 times what? 10 all over what? 4, which becomes what we call, I can decide to reduce it to know where I'm going. 2 here is what? Is 2, and then 2 here is what? 5. 3 times 5 is what? 15 over what? 2, which will give me 7.5. Which will give me what? 7.5. And when it gives me 7.5, I will now go and count. I say 1, 2, 3, 4, 5, 6, 7. Here is my what? My 7. Okay, when it gives me 7, here is 7.5. So 7.5 lies what? At the center. So I'm going to pick the value below and the value above, which is now 9 plus what? 5 plus 9. And 5 plus 9 is what? Is 14. All over what? 2. Which was why we had this into what? To be 7. So this is how to go about measures of quartiles, or what we call the quartiles as it regards the first quartile, the second quartile, and then the third quartile. Another thing we need to mention is what they call the interquartile range and semi-interquartile range. So let me quickly mention that thing before we now go for that of the table. So this is the much we have done, and we want to believe that we have not confused anybody. Thank you very much. When we talk about the interquartile range, we are talking about that this equals what? Q3 minus what? Q1. That's what we call interquartile range. So if I want to find the interquartile range here, my Q3 is 7, it becomes 7. Here is a minus. My Q1 is minus 1, it becomes minus what? 1 over what? 2. And of course, you know that this is 7 plus 1 over what? 2. You can decide to say all over 1, and LCM now becomes what? 2. 2 divided by 1 is what? Is 2, times 7 is what? Is 14 plus. 2 divided by 2, 1. 1 times 1 is what? 1. And you have 15 all over what? 2, which is 7.5. That is the interquartile range. When you talk about semi-interquartile range, you are talking about semi-interquartile range. Semi-interquartile range is given as this equals. Are we there? That this is we'll have it now to be what? Q3 minus Q1 all over 2. So it becomes everything you got here over 2, which is 7.5 all over 2. Okay? So that is what we call the semi-interquartile range. Thank you very much for still following us and still paying attention. We are still committed to make a change in you as long as statistics and mathematics are concerned. The primary objective there is to lift the courage, the determination, which of course are lost in our students about the concepts of mathematics and statistics. We want to lift it up once again so that they will be able to have that courage to approach these subject matters in confidence. Thank you very much. Let us now talk about using a table, finding the table, and the rest of them. So permit me to clear here. Okay, what if now someone has something like this, someone has something like this, something like this, something like this. Then I have something like this. Here is my x and here is my f. I have here to be 0, have here to be 1, have here to be what? To be I have here to be 2, I have here to be 3, I have here to be what? To be 4. By so doing, I've already arranged in ascending order of their values. And let me say I have here to be 2, I have here to be 3, I have here to be 6, I have here to be I have here to be, let me say, I have here to be 1, and I have here to be 2. Let me say I equally have here to be 4. So that here is 5, this is 9, This is 10. Let me have here to be 3. This to this is what? Is a 5, 9, 10. Let me say I have them this way. And the question is for me to find my Q1, my Q2, my Q3. So what I'm going to do quickly is to come here and say that my Q what 1 is going to be given as what? N plus 1 all over 4, which can equally be written as summation of what? Fi plus 1 all over what? 4. So I can sum all my frequencies here to be able to know how many they are. And of course, summing all these frequencies now is, this is 2 plus 3 is what? 5, plus 4, 9, plus 1, 10, plus 3 is 13. So this will be able to give me what? 13 plus 1 all over what? 4, which is 14 all over what? 4. And I can easily reduce that. You say 2 here is what? 2, 2 here is what? 7. And I have 7 over what? Over 2, which becomes what? 3.5. Then I move. If I come, this is the locator. If I come here, I ask myself, here, what I have here is what? Is 2. I ask myself, is 2 found here? 2 is not found here. So because 2 is not found here, sorry, 3.5 is not found here, I will leave here. I will say this 2 plus what? 3 is what? Is 5. Is 3.5 found in 5? Yes, 3.5 is found in 5. Then I will look up now. This my 1 on top here now is what we are going to refer as our Q1. Therefore, my Q1 is equals to 1. But when we talk about Q2, which of course is equals to what? Median, we are going to talk about what? N plus 1 all over 2. And when we talk about this N, we are still referring it to the summation of what? Fi here. So we still can call it now to be 13. And then we have this is 13 plus 1 all over 2, which is 14 all over 2, which becomes what? 7. And I ask myself, is 7 found in 2? No. 2 plus 3 is what? 5. Is 7 found in 5? No. 5 plus 4 is what? 9. Is 7 found in 9? Yes. What is it that own that thing? 2. Then I have that my Q2 is equals to what? 2 here. Okay? So for me to find the Q3, of course, I'm going to do something like this quickly. I have that my Q3, of course, equals. Here is my N, then here is my 3 into N plus 1 all over what? 4. And then we have that this is what? My N is what? Like summation of F, which is 13. So 13 plus 1, I will have that this becomes 3 into 13 plus 1 all over what? 4. Which becomes what? 3 into 14 all over what? 4. To reduce something here, 2 here is what? 2, 2 here is 7. And I'll be able to have 3 times 7 is what? 27 all over 2, which will give me 13.5. And when it gives me 13.5, I am going to come here and ask myself, is 13.5 found in 2? No. Add it to this one, 3. Is 13.5 found in 5? No. Add 5 to 4, 9. Is 13.5 found in 9? No. Add it to this one, 10. Is 13.5 found here? No. Add it to this one. It becomes what? This is 10.5. If you add it to here now, this to this. Okay, here is 13.5. Let me check what happened here, whether my cancellation was wrong. Here is my 13. So I have my, this is 13. 3 by this is 20 what? 7. 27 divided by this, I will be able to have 13.5. So I will definitely check on what happened this place to know why I have to have this to be 13.5. Check it up in our next class. I'll definitely answer you on why this value happens to be the way it is here. Okay? Thank you very much. I really want to believe that you understood very much well about the quartiles as it regards computing it now from what? From an array of data and computing it now from what? A table. Thank you very much. And let us now go over to calculating looking at what we call measures of central tendency in a grouped data. So permit me to clean here quickly. Okay, in order to manage the size of this video of the class, I am going to cut the video now, then set it on again, and then we go over to measures of central tendency and then dispersion as it regards the group frequency table. Thank you very much.